Hello and welcome to my student. Today's lectures we have discussed the topic polymer. In these topics also we have learned some other examples of these polymers. Now first examples we are going to discuss Teflon or another name is polytetrafluoroethylene. This polytetrafluoroethylene they can be prepared by the emulsion of tetrafluoroethylene is subjected to free radical polymerization using peroxide. The reaction is highly exothermic and efficient, stirring by the heat transfer that can be required. So this n number of tetrafluoroethylene molecules can treat with in presence of peroxide and to get a polytetrafluoroethylene polymer. Now we have discussed some properties for those polymers. This Teflon, it is a tough material and therefore it is known as engineering plastic. They resist to heat, chemicals and bad conductor of heat and electricity. For those properties of the polymers, hence they can be used as the coating articles. It is also used to making non-stick, cookware and other the prepare gasket pumps, packing walls or utensils. So this is some uses can be there for Teflon. Next one examples for the polymers are PS. In short, PS means polystyrene. Polystyrene it is a polymer that is can be prepared by the from the styrene. Styrene monomer can be prepared firstly from ethene and benzene by the Friedel-Crafts reaction and followed by dehydrogenation with zinc oxide at 600 degrees centigrade. Therefore, this benzene ring they can be Friedel-Crafts by the ethylene group and to get those molecules. And then after they treat with zinc oxide at 6 degrees centigrade to get it is a styrene. And then this styrene they will be polymerized under the conditions of benzoyl peroxide. Styrene is then polymerized under these free radical conditions using various peroxide like benzoyl peroxide as a initiator. Initiator it means to increase the rate of reaction or start the rate of reaction. Free radical polymerization they will result in a tactic polymer which is amorphous, but catalytic polymerization gives a crystalline polymers. Therefore, n number of these styrene molecules they can be polymerized by using this peroxide and to get polystyrene as the polymer. Having the monomer of polystyrene is the styrene. Now we have discussed the properties for those polymers. Polymer it is a linear polymer and it is chemically resist to acid and alkalis. It is also somewhat brittle and therefore it is soluble in some organic solvent. Then we have see the uses. It is used for making the cup plates. It is used to making TV or the radios. It is also used into a molten polymer by styrofoam which is obtained by making the various packing consumer items. So it is a copolymers of styrene. They can be sulfonated and used as ion exchange resin. Next type of polymer we have see are here the condensation polymerization. Condensation polymerization also called as the step growth polymerization. Condensation polymerization it is a reaction in which the monomer having at least two functional groups must be there. They can react by elimination of simple molecules as like water, alcohol, etc. The large molecules are known as the polymers. Each step of polymerization, they may be independent of the other and hence is known as step reaction polymerization. When monomers have only two functional groups, then can be repeated condensation and to give linear polymers. Linear polymers are the soft, oftenly rubbery substances which on heating soften and they dissolve in the various solvents. For example, the linear polymers and various cross-linked polymers are formed as the monomer and they contain more than two functional groups. They may be hard and have a higher melting point. Now, first polymers we have C polyester. Polyester it is a condensation type of polymer. These polymers can be prepared by the condensation of the monomer having at least two functional groups. They can react by elimination of some of these water molecules. Then we can prepare the monomer can be prepared by transesterification of this ethylene glycol and dimethyl terephthalate. They can be taken as the 2:1 ratio. This can be heated is about 150 degrees centigrade by using the catalyst and to get the monomer for those. And hence this n number for those monomer in can get polymerization at a 280 degrees centigrade in vacuum and inert atmosphere like a nitrogen gas to give a pteryline. The ethylene glycol molecules are eliminated during the ester exchange reaction. The molten polyester they can be extruded into the filaments which are spun into a fiber and they stretched by 3 to 6 times the original length. And to get this is a pteryline polymers. Now we are going to discuss their properties. According to this preparation, the pteryline can be used, this is property, it is a high tensile strength along the axis and it hits as abrasion and crash resistance. It is insoluble in common solvent and it is resistant to soap, detergents, etc. They can be used as mainly used in textile industries by blending with cotton or wool to get various fabrics. This fabric is called as a terry cotton, terry wool, etc. Thin film of polyesters are used into making the photographic films and magnetic tapes. Next, polymers who is called as nylon 6. Nylon it is a polyamide fiber. It is classified into different types depending on number of carbon atom in each monomer molecules. Nylon 6 they can be prepared by the cyclohexanol is first oxidized into cyclohexanone and this is an reaction with hydroxylamine hydrochloride to give a oxime and then this oxime undergo Beckmann reaction or Beckmann rearrangement to give a caprolactam. The polymerization process may be carried out by the caprolactam when heated with the inert atmosphere. They undergoes polymerization to give nylon 6 and this is called as The monomer contains the 6 carbon atoms. Capital atoms, when heated in inert atmosphere, they undergo polymerization. You get the nylon 6 as the polymer. Next polymer we have seen nylon 6,6. Nylon 6,6 it is prepared from two raw materials. They containing 6 carbon atoms, like the name nylon 6,6. They can be prepared. The raw material adipic acid is prepared by oxidation of cyclohexanol. It is a benzene, cyclohexane oxidized to cyclohexanol or cyclohexanol, and which on oxidation with concentrated nitric acid and to produce adipic acid as the raw material for nylon 6C. Nylon 6C is a part of adipic acid. They can treat with ammonia and then resulting ammonium salt. This is ammonium salt is heated and to gives adiponitrile. This is a adiponitrile. This is on reduction to gives a hexamethylene diamine, which is used as a raw material for the nylon 6,6 for the second. Now we have seen the formation of nylon salt. Formation of nylon salt when an aqueous solution of adipic acid and hexamethylene diamine, they are mixed and to get hexamethylene diammonium adipate, which is obtained, it is called as nylon salt. This nylon salt when heated is about 280 degrees centigrade in inert atmosphere of nitrogen. They get polymerized and to use a polymer nylon 6,6, and one of these water molecules may be eliminated. Now we have see their properties. Nylon 6,6 has a greater strength, abrasion, resistance, and elasticity. They can be used to making the various fabrics like hosiery, socks, hosiery, socks, nylon threads used in terracotta, fishing nets. It is also used in various tire cord, bristles, in toothbrushes, etc. Thank you.